My dear students, in a previous video, I have solved some problems in exercise 4.2. In this exercise 4.2, I have solved some problems in the previous video. Now, in this video also, I am going to continue the same exercise 4.2. In this video, I am going to solve problem number 8, subdivision 2 in your textbook. Problem number 8, subdivision 1, we have solved already in our previous video. Now, the second subdivision in problem 8 is prove that the determinant 1, 1, 1, A, B, C, A cube, B cube, C cube equal to A minus B into B minus C into C minus A into A plus B plus C. We have to prove that. For that, I am considering the left hand side determinant and I am converting that the C1 is C1 minus C2. C1 is C1 minus C2. I am going to subtract C2 from C1, that is 1 minus 1. C2 from C1, 1 minus 1, 0. A, C1 minus C2, A minus B. A cube minus B. This is the first column. Similarly, second column C2 is C2 minus C3. C2 minus C3. That is 1 minus 1, 0. B minus C. B cube minus C cube. And that column as it is 1 C C cube. You write as it is. This is our first operation. These two operations we have done in this determinant. Next, 0, 0, 1. First row you write as it is. Second row is also A minus B, B minus C, C. But in the third row, you know the expansion of A cube minus B cube. The algebraic identity A cube minus B cube is A minus B into A square plus AB plus B square. Similarly, B cube minus C cube is B minus C into B square plus BC plus C square and C cube as it is, this C cube. These two are by using algebraic identity I am expanding A cube and A cube minus B cube and B cube minus C cube. Now, from the first column, the next step, I am taking A minus B as a common term. Here, 0 into A minus B is also there, therefore A minus B, A minus B, A minus B. Similarly, in the second column, I am taking B minus C as a common term out of the determinant. That is, see, in the first column, I am taking A minus B out of the determinant, and from the second column, all the elements are multiplied by B minus C, therefore I am taking B minus C out of the determinant. Therefore I get 0, 1, A square plus AB plus B square is the first column. 0, A minus B are taking out, therefore 1. This is A square plus AB plus B square. This is your first column. Similarly, the second column 0, 1, 0, 1, B square plus BC plus C square. This is your second column. Third column is 1C C cube. 1C C cube. Third column. This is our next step of this determinant. After taking A minus B and B minus C from the first and second column, I will get this determinant. And also, now, in this step, I am subtract C1 minus C2 and I get it C1. C1 minus C2. C1 minus C2. And then only you will get 0 here. 1 minus 1, 0. Next step, C1 is C1 minus C2. That is already you have A minus B and B minus C out of the determinant, and C1 is C1 minus C2, 0 minus 0, 0, 1, C1 minus 1 minus 1, 0, A square plus AB plus B square minus B square plus BC plus C square. That is what we have seen. We will find it separately. That is C1 minus C2 is a square plus ab plus b square minus b square minus bc minus c square. Here plus b square minus b square get cancelled. You will get a square minus c square. You will get a square minus c square and plus ab minus bc. After subtracting c1 minus c2 here, I will get a square minus c square plus ab minus bc. That is a square minus c square plus ab minus bc. This is our first column. Next 0 1 b square plus bc plus c square, and third column is 1 c cube. Here also this is a minus b into b minus c determinant. This is 0 0. This is a square minus c square. I can write it as a plus c into a minus c. By algebra of a plus c into a minus c, and plus I can take a outside. Sorry, b. B is common in both of them. You can take b outside. Common term, you will get a minus c. This is your first column. Next, second column 0 1 c. Second column 0 1 b square plus bc plus c square, b square plus bc plus c square, and third column is 1 c c cube. Here also I am taking a minus c common from the first column. Next step, I am going to take a minus c from the first column. I am taking out. I get already I have a minus b and b minus c. I am taking a minus c from the first column as common term. I get 0 0 a plus c. I am taking a minus c outside. A plus c plus b. 0 0. If you take a minus c as common term, you will get a plus c plus b. That is a plus c plus b. Second column 0 1 b square plus bc plus c square 1 c c cube. Third column. Now simple, that over, almost over the problem. Now listen, I am taking minus from this a minus c. I am taking minus outside because c minus c in the answer we have, therefore I am taking minus outside. Minus of a minus b, b minus c, and c minus a. I am taking minus outside. I get minus of a minus b, b minus c, c minus a. And you expand this determinant using first column 1 into, you eliminate third column and first row. It is 0 into b square plus bc plus c square is 0 minus 1 into a plus b plus c. So minus 0 into minus, minus 1 into 1 minus, minus of minus. This minus into minus plus, you get a minus b, b minus c, c minus a into minus and plus, you get a plus b plus c. It is the required answer. That's all about the problem. Okay? Next, I am going to solve one example in your textbook, that is example number 11. Okay? Subdivision 2 over. Next example 11. Example 11. In the textbook you have an example number 11. Prove that A plus B, A plus B plus C determinant. Similarly 2A, 3A plus 2B, 4A plus 3B plus 2C, and 3A, 6A plus 3B, 10A plus 6B plus 3C. This is what determinant is equal to A cube. This is what we have to prove. Okay. For that, first I am writing R2 by R2 minus 2R. So in the left hand side, R2 is R2 minus 2R1, because 2R1 is 2A, 2A minus 2 is 0, you will get that. That's why I am writing R2, subtracting R2, multiplying by 2R. Similarly, R3 is R3 minus 3R. What is our problem? A plus B, A plus B plus C, 2A, 3A plus 2B, 4A plus 3B plus 2C, 3A, 6A plus 3B, and 10A plus 6B plus 3C. This is equal to R1 is, R1 as it is, write as it is, A plus B, A plus B plus C, R1 as it is, right? R2 is R2 minus 2R1, 2R1 is 2A, 2A minus 2A is 0, this is 2A plus 2B, 3A minus 2A, A, and 2B minus 2B 0. If you multiply 2 R2 by 2, 2A plus 2B, 3A minus 2A, A, 2B minus 2B 0. Next, 2 multiply by R2, 2, 2A, 2B, 2C, 2A plus 2B plus 2C, 4A minus 2A is 2A, 4A minus 2A is 2A, 3B minus 2B is B plus B, 2C minus 2C is 0. Similarly, R3 minus 3R1, 3A minus 3A 0, 3A plus 3B, multiply R3, R1 by 3, 3A plus 3B, 6A minus 3A, 3A, and 3B minus 3B 0. Similarly, 3A plus 3B plus 3C, multiplying R1 by 3, 3A plus 3B plus 3C, 10A minus 3A, 7A, and 6B minus 3B, 6A minus 3B, 3B, and 3C minus 3C 0. That's all. Next, one more step here. R3 is, in this stage, R3 is R3 minus 3R2. R3 minus 3R2. What do you get? First row, A plus B, A plus B plus C as it is, right? 0, A, 2A plus B, second row as it is, right? Third row, R3 minus 3R2, 0 minus 3 into 0, 0. 3A minus 3 into R2, 3A, 3A minus 3A, 0. This is 3A, 3 to the 6, 7A minus 6A is A, 3B plus 3b minus 3b is 0. That's all. Finally, you are expanding through column 1, a into, that's the next step. Expand the determinant a into first row, using first row expansion a into a square minus 0. A into a square minus 0 into a is 0. A square into a is a cube. This is right hand side. That's all about the problem. Example 11. And one more problem I am going to solve in the same example in the textbook. Example number 16. It's also very simple, we will see. Let's solve about example next. The example 16 is an important example. Example 16. Prove that 1 plus a 1 1 1 1 plus b 1 1 1 1 plus c is equal to a b c into 1 plus 1 by a plus 1 by b plus 1 by c. That's what we have to do. For that, I am dividing first column by a, second column by b, third column by c. I am dividing first column by a. To compensate it, I am multiplying the determinant by a. Divide the second column by b. To compensate it, I am multiplying the determinant by b. Similarly, third column is divided by c. Compensating, I am multiplying the determinant by c. So, to divide by a, I am multiplying by a. Divide the second column by b, multiply the determinant by b. Divide the third column c, to compensate it, I multiply the determinant by c. So I get 1 by a plus 1. If we divide by a, 1 by a plus 1, 1 by a, this is also 1 by a. This is 1 by b, 1 by b, 1 by b plus 1, 1 by b. Next 1 by c, 1 by c, 1 by c plus 1. This is our determinant. Adding C1 plus C2 plus C3 and write it in C1. C1 plus C2 plus C3. Already you have A, B, C outside. C1 plus C2 plus C3. C1 plus C2 plus C3. 1 plus 1 by A plus 1 by B plus 1 by C. 1 plus 1 by A plus 1 by B plus 1 by C, 1 plus 1 by A plus 1 by B plus 1 by C, 1 by B, 1 plus 1 by B plus 1, 1 by B. Similarly, 1 by C, 1 by C, 1 by c plus 1 as it is. Now from the first column I am taking 1 plus 1 by a plus 1 by b plus 1 by c as a common term. I get already we have a, b, c outer, and I am taking 1 plus 1 by a plus 1 by b plus 1 by c as a common term. From the determinant I get the first column becomes 1, 1, 1. Second is 1 by b, 1 by b plus 1, 1 by b. 1 by c, 1 by c, 1 by c plus 1. See, R2 is R2 minus R1. Next, I am going to write R2 is R2 minus R1 and R3 is R3 minus R1. R2 is R2 minus R1 and R3 is R3 minus R1. So I get A, B, C 1 plus 1 by A plus 1 by B plus 1 by C and R2 is R2 minus R1. R1 1 by B, 1 by C as it is. R2 minus R1, 1 minus 1, 0. 1 by 1 plus 1 by B minus 1 by B, 1. 1 by C minus 1 by C, 0. Similarly, R3 minus R1, 1 minus 1, 0. 1 by B minus 1 by B, 0. 1 plus 1 by C plus 1 minus 1 by C, cancel, you will come. That's all. Expanding to the first column, already you have A, B, C into 1 plus 1 by A plus 1 by B plus 1 by C into 1 into 1 into 1, 1 minus 0. 1 into 1, 1, 1 into this is answer. 1 into everything ABC into 1 plus 1 by A plus 1 by B plus 1 by C, required answer. Okay? That's all about the problem. Example 16. So, I will stop up to this now and we will continue the exercise in the remaining problem in the next video. Thank you.